Hey friends, a very good evening and thank you for joining in. Could you please confirm in the chat window if everything is working as expected, if you can see me clearly, hear me clearly, so that we can get started with today's session in a few minutes. Can you just confirm that? I have my phone here just in case. Okay, good. Okay, so everything seems to be looking as expected. So there is a question which is how important is discrete math in GATE? Very important, because a lot of concepts in discrete math also show up in data structures and algorithms. So it is surely an important topic, you can't skip it, and it's a fundamental topic in computer science itself. Whether it is simple counting, recurrence relations, graphs, trees, groups, all of these are very fundamental in the whole of computing itself. And you have to understand it. There is no escaping that fact. And it's actually easier. Again, if you compare discrete math with respect to engineering math, for example, the electronics and mechanical engineering folks have the electrical and mechanical engineering folks have vector calculus and other topics, which and of course differential equations, which we don't have in CS. So discrete math is the equivalent of it. As important is vector calculus and differential equations to mechanical, civil, or electrical engineering. Similar is it for CS. It's fundamental. Please don't skip it. So Harish has a nice question. What's the vision of applied roots? Very nice question. So from the very day that we started applied roots, we wanted to provide world-class education at an affordable price with great mentorship. That has been the core philosophy with which we started. That students should be able to get really relevant applied education at an affordable price with great mentorship. Of course, the education should be world class. I mean, when we try to teach, even for GATE exam, we try to set a standard which is very high for ourselves. We ask ourselves, okay, imagine if this course was taught at one of the top 20 universities of the world, right? How would we teach it? Especially given that students also have to crack GATE at the end. Right, so that's how we think. Again, we don't only think about academic structures, because most universities don't have an industry relevant curriculum. So we also look at, okay, suppose if a student is learning, let's say, computer organization, how would that knowledge be applied by him or her in the real world after they graduate? So that applied learning is very important core tenet. Of course, unfortunately, GATE don't have very practical questions in the GATE exam. That's unfortunate, but we try to squeeze in some of that in our teaching methodology itself. Cool. No, multivariate calculus is not part of CS syllabus. It's not. So you don't have curl, divergence, you don't have partial differential equations. None of that is there for CS. So that's what I'm saying. That's there for electrical, mechanical, civil engineering folks. I learned some of that because I like math in general, and I wanted to become strong at it. So I learned some of this because I liked it in general. But we don't have it in CS, either in GATE or otherwise. No, we are completely self-funded. We bootstrap the startup with our own savings, and all the profit we make, we pump it back into new products and services that we build. And I mean, this has worked out very well for us, and it's all completely bootstrapped. Very nice. Sovan has a very nice question. I wanted to bring it up today. So in the IIIT PGE exam from IIIT Hyderabad, which was conducted, I think, last Sunday, right, two days back, they had 2 programming questions. I was very happy to see them. They're not hard questions. They're simple questions where we have to write clean code and where you had to handle all the boundary cases gracefully. That's it. Anybody who is prepared for GATE can easily write code for those. I was very happy to see this. And even in my own discussions with faculty members at top universities, fairly senior faculty member at top universities in India, which are also part of the GATE ecosystem, this was one of my feedback suggestions. Again, at Applied Roots, we also conduct boot camps. We're currently conducting 2 summer boot camps at Indian Institute of Science, both for computing background folks and non-computing background folks. So in many of my discussions with faculty members at similar institutes, some of them my friends, some of them very senior folk, one of the things that I always tell them is GATE should be closer to what the real world wants, not just from an academic structure. So one quick suggestion that I can give, if I may, is why don't we have some programming questions Because I'm happy that IIIT is leading the way. Again, IIIT Hyderabad has always been a pioneer. Its course curriculum is actually better than most IITs and also IISc to a large extent, because it's very practical oriented, right? I've hired folks from IIIT Hyderabad for various companies, and those guys know distributed systems. Those guys have used Hadoop and Spark even in their undergraduate days. I mean, that's what education should be, such that it's very applied. People are learning with cutting edge, not just some theory which they may never use, right? So I'm happy to see that. I'm happy that IIIT PG is leading the way, and I hope GATE also becomes like that, hopefully. And this feedback was taken very constructively by some of the people that I've spoken to. And I hope over the next few years, the senior faculty members, also some young faculty, discuss this and say, hey, we should also have coding proficiency as part of GATE examination itself. I hope it happens. Cool. Are you open for internships? Again, what we do every year is Aryan says, do you have any options for internships? So the way we do our internships is very simple. We conduct an online test. We shortlist a bunch of candidates, interview them. We don't care which university you come from. We don't care what background you come from. It's simple. Every year we have some theme. I think last year was programming and data structures. The year before that was machine learning and things like that. Wherever we need interns, we just conduct an online test, and we give a fairly good internship compensation also. It's typically a 3-month internship. And whenever we need interns, we just conduct an online test and say, we don't, because we believe in pure meritocracy. We believe that there are brilliant students everywhere, and everybody should get a fair shot at it. So that's how we do it. What were the questions in PGE? I don't remember them. I have it in one of my chat windows with my co-founders. I don't remember them at the top of my head. So, but they were fairly straightforward. They were not at all hard, to be honest. I mean, fairly simple. If you have studied gate level data structures algorithms, if you have written some basic C code, it should be sufficient. Okay, cool. Again, every year we conduct the internship exam at different points of time. We announce it on all of our channels, on our AI channel as well as our GATE channel, whenever we can think of. Nice, Shaurya. I'm happy that you posted the questions. I think the first question is about some prime numbers within a range. You're given a range of numbers and you have to print, I think, all the prime numbers in that range. Fairly simple, straightforward problem. And the other one was given a number, you have to convert it into its absolute form. It's like implementing the ABS, like in Python there is math.abs. Sorry, there is ABS function, right, which computes the absolute value. Similar stuff also exists in other programming languages. It's a very simple thing. You just have to handle boundary cases, simple, basic data structures, algorithms, basic time complexity, space complexity. You can solve this. I'm happy that IIIT started this process. It's not about the hardness of questions. It's about asking students to write code, because that's what computing is all about, right? Whether you go even into a PhD, whether you go into any field of computer science, you have to write code. And that is a core competency that is not very thoroughly tested in GATE, which should be, ideally. Cool. Yes, these are easy problems. That's what I'm saying. We don't know how these questions will evolve over a period of time. This year, they've kept it fairly easy. So Tanmay says, is there a scholarship on the test series? Unfortunately, no. The only scholarship that we have, that for which we conducted the exam, was for the whole 1-year course. So will you launch any new course? We are actually, again, I think we posted this on our YouTube channels also. We are constantly looking to create new courses, but our bar to create courses is fairly high. We don't want to just create a course because we can, right? That's very, very important for us. And we are trying to collaborate with some of the best experts in the industry and academia to create some really good courses. As and when we make some progress, again, creating these courses is not easy. I mean, there is a lot of effort that goes into them, and there is a lot of expert feedback that also needs to go in. It cannot be done in isolation. That's very, very important to recognize. While you may hear my voice in some of the courses, it is a lot of collaborative effort of our mentors, co-founders, instructors, and even academic and industry experts who have given us tons of feedback. Cool. So there is no other scholarship test for there is no other scholarship test for GATE 2022. The next scholarship test will be for the next GATE, not for this GATE anymore. So somebody is asking about ISI Kolkata. ISI Kolkata has a very, very strong, as the name suggests, this is by Mahalanobis and others who co-founded Indian Statistical Institute. Phenomenal. Again, Mahalanobis distance is a very interesting metric that we study in machine learning and statistics. So it's a terrific institute. Even their computer science program is very good. I've had the opportunity to work with stats guys from ISI, also CS folks, and their CS also tends to be more mathematical in nature. So if you like the mathematical aspects, or even if you like machine learning, data science type of stuff, ISI is a very good place. It's a small place, very math oriented, just like the way you would find a TAFR or Chennai Mathematical Institute. So if you have that mathematical inclination towards CS, or towards some areas of CS, especially statistics oriented or algorithms oriented, it's a terrific place to go to. I mean, no worries about it. Again, if you want more details, just email us your context, and one of our co-founders who has actually cracked ISI can give you more details about it. Cool. Okay, it's 7:08, so let's get started with the live session itself. As always, I promise you, we will get back to the Q&A at the end, right? So let's get started now. Hey, thank you folks. Thank you for reminding. I lose sometimes track of time. Thank you for reminding. So today's live session is again data structures part 4. I think there are 7 parts till probably roughly the middle of this month. So today it's all about trees and heaps and things like that. Very important topic, both from your placement perspective, especially heaps, and also of course BSTs, binary search trees. Very, very popular in interviews, also very popular in GATE. So we'll solve a bunch of questions. Today we have slightly more interesting problems, fewer easier problems. So take your time. Cool, here is an MSQ. Again, we will surely answer your general questions at the end, right? So please, let's focus on solving the questions now. The general questions about various universities, courses, we'll surely answer them at the very end. Let's get into the questions. It's an MSQ. So take your time, think about it. Again, please take your time. It's an MSQ. Please be careful. I see a lot of answers in the chat windows. Please revisit your answers. Please don't be in a hurry. Think through. Again, I see some of you not reading the question carefully. Read the question carefully. To the best of my knowledge, it is self-sufficient. No other information is needed here. I see a huge spectrum of answers here. So please be careful with your answers. I see a lot of mistakes also. Don't miss checking any option because it's an MSQ and you should go through all the 4 options. Oh, it seems there was a similar question in IIIT exam. I think similar questions we find at many universities and even I think previous year gate questions if I'm not wrong. Take some more time. I see a lot of incorrect answers to the best of my knowledge. So again, today will be slightly more interesting questions. Slightly more on the medium and tricky side rather than the easy side. Some of you got it right. I'm happy about it. But a vast majority of you got it incorrectly. Okay, so let me start answering it. So what does it say? Which of the following are invalid sequences of comparison values that a key is compared with when searching for a key in a binary search tree? So imagine we have some key. We don't know what that key is, right? We don't know what that key is. But this key would be compared with various values when you're actually performing, we're trying to find this key in a binary search tree, right? Which sequences are invalid, not valid? The question is asking the negation, which are invalid. So first let's see A. So let's assume first I compare with 50, okay? Then after that, what is my next thing that I'm comparing? 70, which means if I'm comparing 70, 70 can only be there in the right subtree, right? It can't be in the left subtree, which means the value that I'm looking for has to be greater than 50. That's why I've come to the right subtree. Right? And I only discovered that after seeing the 70 number. So draw the structure of the tree and see if there are any inconsistencies. Okay, after 70, my next search value that my next comparison value is 60, which means what I'm comparing with, okay, 60 can be here. Perfect. And whenever you're adding a number, check, can 60 be there in this subtree? Yes, because 60 is greater than 50 and it is less than 70. Perfect. Then you have 59. 59 is less than 60. Now, can 59 be present here? Yes, 59 is greater than 50. It is less than 70. It is less than 60. So till now everything is okay. Such a binary search tree can exist, okay, with these values. Then you have 52. So 52 will be placed here, right? 52 will be placed here. Can 52 exist here? Yes, it is greater than 50, less than 70, less than 60, less than 52. Perfect. Then the next number that we are comparing with is 55. Right? Next number so 55 has to be there on the right side here. Can 55 be present here? Logically, yes. 55 is greater than 50, that's why it's there in the right subtree. It's less than 70, it's there in the left subtree. It's less than 60, less than 59, greater than 52. So this is also all right. The last number that I'm comparing with is 58. Where will 58 be? 58 will be there on this side. Okay, that's the last number. Can 58 be logically present here? Yes. Again, check. Greater than 50, that's why it's there in the right subtree. It's less than 70, perfect, that's why left subtree. Less than 60, that's why left subtree. Less than 59, right, that's why it's there in the left subtree. Greater than 52, greater than 55, 58. So this sequence is perfectly valid because this sequence is consistent with the structure of a binary search tree, right? So this sequence is valid, but the question says which of them are invalid. So this can't be the answer, number one. Number two, let's look at this. Again, it's all about thinking through how does a binary search tree look like. First you have 10, okay? First I'm comparing with 10. Then I'm comparing with 40, which means my number my key that I'm comparing with has to be greater than 10. That's why we come to the right subtree. Then I have 15. 15 will be there here. Can 15 be present here? Yes, 15 is greater than 10 and less than 40. So no issues till now. Then you have 20. 20 will be fixed here. Perfectly all right. It satisfies the condition that it is greater than 10, less than 40, greater than 15. Perfect. Then you have 25. 25 will be here. Cool. Till now everything is looking good. 25 greater than 10, less than 40, greater than 15, greater than 20. No inconsistencies. Next you have 45. Where will 45 be? 45 will be here. But do you see a problem now? Look at this. How can 45 be there on the left subtree of a binary search tree? This is the left subtree, right? There will be some other right subtree. How can 45 be here? 45 can't be here. It's impossible, right? Because only values that are less than 40 can be there in this subtree. Sometimes, depending on the implementation, it can be less than equal to 40. But this value is strictly greater than 40, right? Look at this. It's greater than 10. It's consistent with respect to 10, but it's not consistent with respect to 40, which means this sequence is not a valid sequence of search comparison values. So B surely is an answer. Again, same process. So A can't be the answer, B can be the answer. Just repeat the same process. Again, 12, yes. My next number that we're getting is -1. So we go to the left, cool. Then we have 6, perfect. 6 is less than -12. Sorry, 6 is less than 12 and it's greater than -1. Consistently going. Then 0. So 0 will be this side. It's satisfying all the requirements. Less than 12, greater than -1, less than 6. Then you have 3, 2, 1. So where will 3 be? 3 will be here. Satisfying all the requirements. Less than 12, greater than -1, less than 6, greater than 0. Similarly 2. So where will 2 be? 2 will be here. It's satisfying all of the consistency checks. Then again 1 will be here, satisfying all the consistency checks, right? So C is also consistent. This is valid, and hence this won't be the answer, right? So till now only B is an invalid sequence because we're looking for invalid sequences. Now let's go to D. Okay, just draw the tree here. Same logic. You have 100, so 50 consistent. Then you have 20 consistent, 10 consistent, 15 consistent, 17. So 17 will be greater than this. Then you have 18. 18 is also consistent, right? Just let me check. It's less than 100, less than 50. It's less than 18. It's greater than, sorry, it's less than 20. Yes, greater than 10, 15, 17. This is also a consistent sequence. So this is consistent and hence it can't be the answer. So the only answer, the only option, while it's an MSQ, the only valid option is B. Rest everything is not the correct option to choose. Very simple question. We're just asking, if you go through this sequence and build a binary search tree, is it valid? This is a good 2-mark question. Again, this question is not hard. It is just tricky. Again, you could call it medium tricky or even sometimes easy tricky. I would actually rate it somewhere between easy and medium. It's not actually very easy. At the same time, it's not even medium, but it's certainly tricky. You have to be careful to think through, right? Very simple question, straightforward question. But of course, you have to be careful. Okay. So somebody says, why can't we take the last element as the search query? Because the search query can also fail, no? This may not be the key. This may not be equal to the key. It need not be equal to the key. Don't always assume that it is the key. Because in a binary search tree, a key may not be found in a binary search tree. So you can't always assume that it will be found. One key observation here. Again, as usual, draw things. Visualize things, draw things. That's a super duper useful thing, especially if you're thinking about BSTs, heaps. They're very visual things. Trees are very easy to understand and visually grasp. So use them. Second, most people who got it incorrectly got it in a hurry. I've seen so many people, I think the first 10 answers were incorrect, right? So please don't be in a hurry. Accuracy is more important here. In GATE, you will get about 3-4 minutes to solve this. So try to, this most likely will be like a 2-mark question. Don't be in a hurry to solve a question. Be consistent in accuracy because all you need is approximately 70 out of 100 to get a very good rank, right? Even if you get 60, you'll get a decent rank, but with 100, you'll get a very good rank, okay? You don't have to get 100 out of 100. Don't forget that simple fact. Cool, let's go to the second question now. This is a nice question. If I'm not wrong, there was a similar question, not the same question, similar question in 2018 GATE, which we have also solved in our course videos as a solved problem. Similar question, not the same. Take your time, be careful. This is also a good 2-mark question. Sometimes 2 marks, but mostly 2 marks. Again, for some of the general questions, our team is trying to answer them via the chat window. I'll surely tackle some of them at the end of the session. For now, let's solve the questions. Again, typically in GATE, they will say 3 decimal places, or let's say 4 decimal places, right? So round it to 4 decimal places or something like that, right? Typically, most NAT questions are like that. But it's okay. Even if you give a rough answer, I will take that. This is a question in the intersection of combinatorics and heaps. Again, you don't have to remember any formulae for this. You can solve this from first principles very easily. That's what we always encourage. Don't go behind formulas unless it's absolutely necessary. Try to solve things from first principles. I see a few correct options for sure, correct answers being put in the chat window. I also see a lot of variability. So please recheck your answer. Again, it will be good to see how many of you actually derived this and solved it. How many of you remembered some formula? I would like to see that in the chat window. Could you just mention that so that I get an idea on how many of you just remember a formula, or how many of you are trying to derive it from first principles? Good. Some of you are deriving it from first principles. Very happy to see that. That's a skill that will stay with you for a lifetime. That's the problem solving skill. Again, I'll also derive it from first principles and very visually. Let everyone solve it for a little while. Let's see the answers. Yeah. So once you know the technique, you can solve it for any number of unique integers. You can build a min heap very easily. Or you can find the number of min heaps. That should be, once you know the method, everything falls in place. Okay, cool. Let's wait for a few seconds because I believe some of you are still trying to solve it. Okay, so let me solve it for you. an array of 7 unique integers, this is helpful, is rearranged randomly and chosen. What is the probability that it represents a min heap? So if you have 7 unique integers, in how many ways can you arrange them, right, into an array? This is not circular or anything. This is simple array, right? So you can arrange them in 7 factorial ways. Simple 11th class probability, 11th class combinatorics, right? There are 7 places. In the first place, you can place any of the 7 values. In this next place, any of the remaining 6, any of the 5, so on and so forth. 7 factorial, straightforward. Now, what is the probability? It represents a min heap, which means now we have to count the number of min heaps that you can construct. Of all these, basically if you're given 7 unique integers, how many min heaps can you construct? The number of min heaps you can construct. That number, let's just assume that number is n, then the answer will be n by 7 factorial. That's it. Now the challenge in here is to count the number of min heaps. That is very interesting. Okay, let's tackle that step by step. So we have 7 unique integers, right? So the root, again, remember, a min heap has to be like a complete binary tree. Okay, it has to be a complete binary tree. That's important. That's in the definition of what a heap is. And every node should be less than its less than its children, right? So if you have 7 unique integers, the smallest value will always be the root, right? So if you look at the root itself, this will always be the minimum value, and there is only one way to fill this minimum, to fill the root, right? There is only one way to fill it. Because all integers are unique. Of course, this question can be made fairly tricky if some numbers are repeating. That will become a much more challenging problem, right? But that will be mostly on the harder side. This question is by gate standard, it's somewhere between medium to hard, right? Again, gate never asks you hard questions, so it's somewhere in between medium to hard by gate standards. I wouldn't treat it as hard. I would still consider it as medium because it's easy to derive this. The root has to be always minimum value, and there is only one way to do it. Then you have 2 subtrees, right? So first let's look at the left subtree. In the left subtree, again, this has to be a complete binary tree, right? So there will be 3 elements here, there will be 3 elements here. So you will have a root, you will have 2 values here. Similarly, you will have a root, you will have 2 values, right? Simple. These are the 2 subtrees. Now, if you have 3, again, you can place 3 values here and 3 values here. So to create this subtree, you can choose of the 6 remaining elements, you can choose any 3 elements. So 6 choose 3 ways, right? Again, you will place 3 elements here. Again, the rest of the 3 elements, there is only one way to pick them, right? So imagine you have 6 elements here, right? In how many ways can you pick 3 elements from this? 6 choose 3. So let's assume you pick these 3 elements. The remaining 3 go into the other side of the right subtree. Right? That's straightforward. So if the number of ways you can pick the left subtree will be 6 choose 3. Once you do that, right, there is only one way to pick the right subtree. Now let's go in. Within the left subtree, look at this, within the left subtree, in how many ways can I pick the root node? Only one way. Because the minimum has to always be the root node here of this subtree. Now amongst these 2 values, there is no order that is required. The minimum, again, this has to be the minimum within this subtree, within these 3 elements that you have picked. These 2 elements can be in any way. So this element I can pick in any 2 ways because there are 2 elements left, right? This element I can pick in any one way. Again, look at how I'm trying to break the problem down into its smallest components, right? Now, since you have picked 3 elements from a set of 6 elements and placed them here, 3 more elements are left. In how many ways can you pick the root now of the remaining 3 elements? There is only one way to pick this minimum. Now we are left with 2 elements. Those 2 can be placed anywhere. So this node can be any of the 2 elements. This node has to be the remaining element, right? So let me erase this 3 here. Let me erase this 3 here. So now what are the total number of ways in which you can construct this? Root node only one way, right? This subtree is 6 choose 3, right? Once you pick 3 elements for the left subtree, one way minimum, right? This node you can pick in 2 ways. This node you are left with only one way. Next, this whole subtree, there is only one way to pick it because 3 elements you have placed here, the remaining 3 will go here. This root node, only one way to pick it. This left child, 2 ways to pick it. The right child, only one way to pick it, right? I hope I'm right here. So this will be, okay, let me just erase this and write the math here. It will be 6 choose 3 into 2 into 2 if you just ignore all the ones. So 6 choose 3 is 6 factorial by 3 factorial into 3 factorial into 4, which will be 6 into 5 into 4 by 3 into 2 into 1 into 4. So this is 6, 6 cancels out, 5 into 20 is 80. So your n equals to 80. So all you're left with is 80 by 7 factorial, which some of you got it, right? Which will be, what will this be? 0.0159, approximately. So the easiest way to think about such problems is to draw this diagram and say, hey, how many ways can I pick this? How many ways can I pick this? Some of you often, the common mistake here is forgetting this 2 ways. People think that they're building a binary search tree. They're not building a binary search tree. They're building a min heap. That is the confusion that many people have. There are 2 ways of picking this. There are 2 ways of picking this. The same problem, you can expand on it. So let's assume Tn is the number of ways you can build a min heap with n elements. You can write a simple recursive equation, right? So Tn will be equals to 1 if n equals to 1, right? If n equals to 2, right? Again, it will be 1, right? Because the minimum element becomes the root, the other element becomes this. Similarly, it will be equal to 2 if n equals to 3. So on and so forth. The recursive part will be within all these n elements, you pick the smallest element. Again, this is if you have n unique values. Only then this whole thing will work. You pick the smallest one. Look at this. The smallest one, because you're building a min heap, becomes the root. Then you have a left subtree and a right subtree, right? How many elements are there? Total n minus 1 elements are left. So from these n minus 1 elements, you can choose any k elements to be placed in the left subtree, right? These k elements, again, you will write an equation like this. Tk, t n minus 1 minus k. This is the recursive equation that you can arrive at if you think about it logically. Of course, this k, again, because we have a min heap, which is a complete binary tree, if this is not 7 but some other number, you have to ask yourself, what will the k value be? Right? Very simple question. But this way is slightly harder. Solving this recursive equation will be slightly harder. For a question where n is small like this, even when n is 15 or 20, you can actually build this tree and work it out manually. I prefer this type of working out because it is visual. I can think of like placing some number here or placing a value here. It feels very physical. It feels like playing a game. And I mean, at least it comes naturally to me and I enjoy it, right? So this is one way you can solve it. Okay, cool. This is a very nice problem and some of you got it right. Again, there are some follow-up questions that the team is answering. So in the meantime, let's go to the third question. This is also a question about sorting and min heaps. Very nice question. Again, in the previous question, if n is large, you can work out using the recursive formulation, which will not be easy, but you'll have to probably write code for that. Again, please read the question carefully. Since this is an MSQ, it will most likely be like a 2-mark question in GATE because you have to go through all the 4 options. But this would be easy to medium. Actually, I would call it easy, but then because it's an MSQ, you have to be careful. Very happy to see a lot of correct answers in the chat window. Very happy to see this. Good, good, good. I'll wait for a few seconds and go into the solution, since many of you got it right. So I'm assuming it was straightforward for most of you. Okay, so let's start solving it. Which of the following are true, is or are true, if duplicate elements are not present? It's an MSQ, so let's go through each of the 4 options. Every min heap, if considered in level order basically means first you go through the root, then you go through this level left to right, then you go through this level left to right, so on and so forth, right? Is always a sorted array in ascending order. Is that actually true? Can we construct a counter example? Imagine there is 10 here. Right, so first element will always be the minimum element, so that part is sorted. Ascending order, right? So no duplicate elements, so less headache. So between these 2 elements, there is no order that is prescribed when you're building a min heap. The min heap only cares about this value as compared to these 2 values, that this should be less than equal to these 2 values. That's all min heap cares about. There is no relationship between these 2. So what if I place 15 here and I place 12 here? When I do a level order, again, this is going to satisfy the conditions of, let's assume that's all is my tree. Let's assume there is no subtree here. This is a perfectly valid min heap. But when I do a level order of this, 10, 15, 12, I'm not getting a sorted array in ascending order. So this option surely is incorrect. You can easily get through these cases by simply working out simple examples, right? Very simple examples. Now, every sorted array in ascending order represents a min heap when interpreted as a binary tree, right? Okay. So very simple. So you typically, when you interpret as a binary tree, how does this whole thing work? This will be the first element. Again, your heap can also be like this, right? So first element, first location, second, third, fourth, fifth, sixth, seventh, eighth. This is how you store a binary search tree in an array. And they're saying it's sorted, right? So this value will always be the lowest, right? This value and this value, remember, because it is sorted, right? This value will be less than this value. So this will be 2, this will be something like a value greater than 2. I'm just putting some values here. And since it's again sorted, these values will always be greater than these 2 values. So there will be some 4, 5, 6, 7. This value will be greater than all of them. Is this a heap? Every sorted array in ascending order. Again, I'm just placing some numbers here. But the catch here is, if when you go through level order, you will get, again, that's what it means, right? 1, 2, 3, 4, 5, 6, 7, 8. This is the level order. The level order will be your sorted array, and that will be the interpretation of the binary tree using an array, or implementation of a binary tree using an array, right? So when you do that, this is certainly a heap. Every sorted array in ascending order represents a min heap because it will satisfy the conditions of the min heap, right? This is a complete binary tree. Obviously it is, right? Number 1. Number 2, every node here is less than equal to its children. That condition is also satisfied. So B is always true. Simple. So B is true, A is not true, C. C and D, if you think about it, are exactly A and B, but with min heap replaced with max heap, ascending order replaced with descending order, right? Of course, it's always better to just work it out carefully. So every max heap, if considered in level order. So imagine I have a max heap like this, some 20 here, some 15 here, some 12 here. Okay, so let me do the other way, okay? So imagine if I have 12 here and I have 15 here. Okay, so if I do level order, I get 20, 12, 15. It's not in sorted order. It's not in a sorted array in descending order. No. So this is surely not true. Similarly, the last option, every sorted array in descending order represents a max heap. Same logic as B. So B and D will be correct. The same logic that we applied for B, right? If you actually take a binary tree represented as an array, you'll always have, of course, it's sorted in ascending order. So this value will be always greater than these 2. This value will be greater than these 2. This value will be greater than these 2. This value will be greater than this, right? Because it's already sorted in descending order. So obviously D is correct, B and D. This is an easy question. You just have to read the options carefully. Take a simple example and it will all work out for you. Okay, cool. Okay, so this is an interesting question. Please read this very carefully. Take your time, work it out carefully. Again, this is not the same as actual coding questions, because here you're given code and you have to fill in the blanks, which requires a slightly different mindset than actually writing code from scratch. Take your time. Please be very, very careful with this. This is a good 2-mark question in GATE. Yeah, this sort of problem is very common in interviews. Like you're asked to implement a function that gives you the diameter of a tree. It's a very common interview question. Again, the interviewers mostly ask this because people commit silly mistakes in this. And this question is not same as a typical interview question, because here you're already given code. You have to understand the code and fill in the blanks. That's a different skill. Again, please be careful with this. It's very easy to commit mistakes. Take your time, work it out. No hurry. Don't fall for the names of variables. Anyway, let's work it out in a while, but please rethink your answers. So what is diameter is clearly defined in the question itself. Don't fall for the variable names, right? Because there is no rule that they should be named in a specific manner. So work it out, carefully work it out. I'll give you a hint. Work out a simple example. Take a simple tree, and work out the boundary cases. Again, the final diameter that we want should be in this integer pointer, or it should be in this memory location, right? That's what it says. And it will return it via the diameter parameter by reference. But this function also has another return value, which is integer. So you have to be careful how you work with these two. That's why I said this question is on the trickier side. I think almost all the 4 options being picked by folks, A, B, C, D. Think of simple boundary cases. Again, this code may fail in some cases, but let's try to get it as accurate as possible. Okay, so let's solve it together. Okay, maybe I am wrong. I'm happy to accept if I made a mistake, but let's think through it. Okay, this was tricky even when I solved it on my own. Like, I had to be very careful because literally the only difference is whether there is a +1 or there is a +1 here or not, right? Those are the 4 options. Okay, when you're computing max diameter, will you have +1 or not? When you're returning, will you have +1 or not? Those are the only 2 options. So one way to tackle this, I'm not saying it's the only way, is to start with the simplest example. Imagine you have only a single node, nothing else, right? Imagine if you have just a tree with a single node. What is its diameter, right? Its diameter is 1, because any path, see, there is only one node here, right? There is literally only one node, right? So how many nodes will be there in any path? There is only, how many nodes will be there? There will only be one node. That's what is the definition of diameter, right? The diameter of a tree is the number of nodes on the longest path between 2 nodes. Again, if you say, hey, this is too much of a boundary case, because is diameter even defined if you have only one node? So let's take a slightly more interesting example. Let's take this example, okay? Or else let me just draw it carefully here, because I need some space for explanation, okay? So imagine if there is, so if one node, because it says between 2 nodes, some of you might argue that, hey, is diameter even defined if there is one node? So let's avoid that boundary case. Let's take a much more simple case like this, okay? Or you can even start with one node case if you agree to that definition, and you can eliminate some options with that, okay? Let's start with one node, then we'll go to the 2 node case also, step by step. I'm just trying to teach you the thought process behind it. Okay, imagine I have this. This diameter value will be returned by reference, while because we're just filling data into this memory value. We also have this return. This return will play a role here, right, in getting the left height and right height. Again, the variable names can be anything. Please don't fall for the variable names, because that's how questions can be made tricky very easily. Okay, so now we have this, okay. So we pass the pointer to the root node, okay. Is root equals to null? No, it's not equals to null. Of course, its left subchild is null, right subchild is null. Then it says left height equals to get diameter. Okay, so it passes this. It passes this left child, which is basically null. So what would this return back? This would return 0 to you. So your left height, look at this, your left height will be equals to 0. What about your right height? This will also return 0. So your right height variable will also be equals to 0. Right? Simple case. If you agree that the diameter of a tree can also be defined when there is only one node, and the diameter should be 1, right? For a single node, if the diameter should be 1, then let's work it out, okay? I'll also work out slightly different cases for you. Then what should this line be? Look at this. Because this max diameter now is being used, initially your diameter by default could be something like 0 when you're calling this function. right? Whatever value you store in this diameter memory location could be 0, right? So this max diameter now is what will be determined with this first line. Okay, there are literally only two options: max diameter equals to left height plus right height, or left height plus right height plus 1. There are literally only two options here. So let's assume we only have left height plus right height. Then what will happen to the max diameter here in this node, right? When the recursion finishes and when we come back, your max diameter becomes 0 plus 0, right? Cool. Then your diameter will be max of these two, which will be 0, right? Then what happens? The next step. Okay, so let me use a different color. It's getting cumbersome because of limitations of space. Then diameter will point to a 0 value, right? Then what will you return? What you return here doesn't matter enough, because what is the purpose of it? I don't care about this return value here. I only care about what value you are placing in this memory location, right? Whatever you place here, I don't care right now, okay? Because we want to place the diameter of this graph, or of this tree, I'm sorry, we want to place the diameter of this tree into diameter. And what is being placed here? 0. Well, what we want is 1, which means surely max diameter equals to left tree plus right tree may not be the right option. Maybe we need to have plus 1 here, right? If you had plus 1, the diameter value will be 1. And that's what we will return by reference. So if you take this boundary case, extremely boundary case, then you can decipher very quickly and eliminate option A. You can also eliminate option D. Then you're left with B and C, right? Because if you see, there is plus 1 here, there is plus 1 here when you're computing max diameter. So to solve problems like these, what is important is think about the boundary cases, because all these questions are designed using boundary cases. Okay, now let's take one more tree like this. Simple tree, only 2 nodes. This is the root node, this is the right child. Okay, let's work it out using this now. Okay, so obviously this will point to null, this will point to null, this will point to null. Now let's work it out and go step by step again. Okay, so again, I'm just doing it carefully. I'm just doing it, again, when you actually solve it in the exam, you can do it much faster. I'm just doing it carefully so that you understand the thought process on handling boundary cases. Okay, so we pass a pointer to this, cool. Is the root null? No, so this part is not a problem. Then you go to the left node, right? Get diameter of the left node. So when it goes to the left node, what would it return? Because it is null, it will return 0. So the left height will be equal to 0. What about the right height? Again, it will still not return. So this will recursively call this, it will return left height equals to 0, right? With respect to this node. Now let's look at this node, right? This will call this because of this. It's a recursive call, right? This will again call this will return 0 as left height, right? This will return 0 as right height equals to 0. Now we know that this line here should be max diameter. I'm just writing it here. Max diameter equals to left height plus right height plus 1. Now we just plug it in, right? So what will max diameter variable be when we again recursively we'll keep coming back, right? The max diameter here will be equals to 1, right? That's what will be computed, right? Now, okay, then the diameter value will also get changed here. So diameter value will now point to 1, right? Because it is a max of max, it's a max of max diameter and whatever value were earlier there in diameter. Cool, so till here everything is good. Now what should the return statement be? What should we return here? That is the question, right? Let's take, see, between B and C there is only one difference. Is there a plus 1 here or not? That's the only difference, right? Now let's take the case where there is plus 1. Okay, we'll also see what happens if there is no plus 1. Now then what happens? What will your right height? This will return some value, right? So what is it returning? It's returning left height plus right height plus 1. So what is the left height that we have here? Look at this. With this node, the left height variable is 0. The right height variable is also 0. So this will return, remember this will return max of, it will return max of right height, left height, which will be 0 again. Max of 0, 0 is 0. 0 plus 1 is 1. Let's see if this works. So when you come to this node now, recursively you're coming back, right? When you come to this node now, what you have here is left height equals to 0, right height equals to 1. Okay, now let's work out. With respect to this node, let's see what will happen now. Okay, so with respect to this node, you got this, you got this. Now max diameter will get updated. So what will max diameter be now? Max diameter will be left height plus right height plus 1. Left height is 0, right height is 1 plus 1. So max diameter will become 2. Now what will diameter become? Diameter will be max of 1 and max diameter, which is 2. This is pointing to 1, this is 2. So that will be 2, right? And what will you return finally? Look at this, what will you return? You will finally return left max, so left height is 0, so you'll return max of 0, 1 plus 1. So you'll return 2 here. But what you return, I don't care, because I want to get the diameter in this pass by reference. So my diameter is 2. Perfectly all right. Given this graph, my diameter should be 2. Because in the longest path, there are 2 nodes here. Some of you may have gotten confused between nodes and edges. In the longest path, there are 2 nodes here. Imagine if I did not have this plus 1, what would happen? Imagine if this plus 1 did not exist, then this right height would have been 0, and I would not get a diameter of 2, I would have gotten a diameter of 1, which is incorrect. So the only right option is C and not B. Again, for most questions like this, because you're not writing the code. Again, if you're writing this code in a competitive programming environment, that requires a different skill. Of course, even when you're writing code, you have to break the problem recursively into smaller parts, handle everything gracefully, also handle boundary cases. But in the gate, typically, such questions expect you to handle boundary cases. The easiest way to solve these questions is to handle simple boundary cases, like what if there is only 1 node? What if there are only 2 nodes? Because once you work it out, everything pans out, right? Very simple. Again, this question is not hard. This question is just tricky, and you have to be careful here. That is the key. Some of you got C as the answer, but I've also seen A, B, C, D. I think some of you have gotten carried away with the variable names. Some of you haven't thought through the simple boundary cases like these. Again, some people can argue that this is not a valid boundary case, but this is a valid boundary case. Even if you work out one boundary case, actually when I solved it on my own, I was just thinking of this simple boundary case. That's all, right? So it's a good question. It's a question from the competitive programming world, which has been modified into a gate format. Okay. Okay, sounds good. So let's go to the next question here. The last question of the day. Again, I can completely understand that some of you got confused between edges and nodes. That's why I asked you to read the question carefully. Okay, this is the last question of the day. Then we'll have discussion. This is like a good 1-mark question. This is the easy question of the day, if I have to pick one. Good to see many of you got it right, which means probably you've solved a similar question, or you're good. I mean, this is a slightly tricky question if you're not careful. If I'm not wrong, we have also solved a similar question in the solved problem section of our GATE course content. Oh, good. It seems a similar question. Yeah, I think a similar question was there in GATE 2021 also. Yes. This is also a nice standard interview question. Sometimes most top companies, when they come for campus placements also, they have a shortlisting round where they give MCQs like these. Anyway, in the interest of time, so that we can spend some time in Q&A, let me answer this. So the answer is C. So some people might think that, okay, I have a min heap, so I can do heapify and all that, and I'll just do it 10 times. Actually, you don't have to do it. If you're thinking from a time complexity perspective, look at this. The first smallest element will always be there in a min heap, right? Will always be there in the first smallest element will always be here, obviously, right? The second smallest element, right, will be there in this level or the levels below that. Similarly, the third smallest element, right? The third smallest element will always be there in the third level or in the levels above that. right? If you think about it logically. So the 10th smallest element, right? The 10th smallest element will always be there at the 10th level or lower, right? Now, how many nodes are there in this level? There are 2 power 0 nodes. There are 2 power 1 nodes here because it's a min heap, right? Maximum I'm talking about. So 2 power 2, so on and so forth, 2 power 9, right? Because if you see, this is the third, for the third smallest element, you have 2 power 2, second 2 power 1, first 2 power 0, so 10th smallest 2 power 9. So if you sum up all of it, you'll get 2 power 10 minus 1, which is a constant. So all you have to do is check through these 1000 odd, I mean, this is what, 1023, right? So just compare, just look at all these 1000 elements and you would find the 10th smallest element amongst them. And you can do it in order of 1000 elements, which is in terms of time complexity, it is actually order of 1, right? So simple logic. So it's actually order of 1. Again, so some people might argue that, okay, isn't order of log n also correct? But whenever a time complexity like question is given, you should always pick the tightest bound or the most appropriate answer. So you can solve it in order of 1. Of course, there is another way to solve it, which is 10 times take this, take it out, right? And keep repeating, reheapify, you'll get the second smallest element and so on and so forth, right? So that's the approach here. Cool. So even if you have the same elements, right? Suppose if all the elements are the same, that's a boundary case here, right? Even then, the 10th smallest element, right, will be that, say, suppose let's assume all these 1023 elements are the same element, right? Then the 10th smallest element will be that element itself, right? That's how you count it, right? Cool. Again, this is simple. As long as this value is not a function of n, which is the number of elements, you can simply say the time complexity is order of 1. From a time complexity standpoint, okay? Straightforward, easy question. If you're just careful, you'll get it. Now with that out of the way, let's get into the chat window and let's tackle some questions. Cool. Cool. I have my phone here, so let's look at some questions. Feel free to, again, whether you're given max heap or min heap, whether you're asked to find the largest or the, respectively the largest or the smallest element, the math doesn't change. Cool. So Ayush says, people giving second time always have an edge. I'm preparing for the first time. Do you think it's harder for first time people? It's not. Because of course, people who are preparing second time, they have an advantage. Let's be honest about it, because they've put in more effort. But it is not just the volume of effort that matters. It's how smartly you're putting in that effort. We have seen people who have attempted GATE 3-4 times also. And because they've never focused on the foundational skills of both conceptual clarity and problem solving skills, they never cracked it, unfortunately. Even people who are cracking it the second time, probably they didn't get a very good rank the first time around because they're lacking either foundational skills or problem solving skills. So if you build that, the competition is fair, right? So Yash asks about IIIT Delhi. Again, that's another institute that is picking up very well. We also have spoken to a few students there. And IIIT Delhi is picking up. Of course, it's in a nice cosmopolitan city, which means more placement opportunities and things like that. And and when companies come to other universities in Delhi, especially IIT Delhi, it makes sense for them to say, hey, let's finish IIT Delhi and also go to IIIT Delhi, which is generating some good students. So I do see, especially IIIT Delhi, IIIT Bangalore picking up steam. Their course curriculum is also getting more and more closer to what companies want, just like IIIT Hyderabad. So they're certainly picking pace, and I think it's a good option. Again, you should see their curriculum, what branch, what exact program you're getting into. And best thing always is look at people who graduated last year or the year before that, see where they are right now. You can go to their LinkedIn profiles, ping them. I mean, that's a great, I mean, if you're career oriented, not research oriented, that's another thing that you can look at. Is English needed much in tech companies? If sound technical knowledge is there? No, not so much. Of course, you'll have to write some basic English or reasonable English and speak reasonable English. But I've worked with folks from all parts of the world. I've worked very closely with phenomenal engineers whose English is extremely hard to comprehend on a phone call. So I mean, these are like hardcore, like solid distributed systems engineers who have grown heavily in their careers. And just like we Indians have our own accent, Chinese have their own accent, the French have their own accent, the Moroccans have their own accent. So there will be always those issues of communication gaps, especially if you're working at large companies. But you learn the basic etiquette of how to communicate in written form. There will always be some friction when you're working in multicultural teams, but as long as you can, basic communication is there, I think you're good enough. And anyway, that's something that you'll pick up on your job. So don't worry too much about becoming good at English communication. I'm not saying it's bad. Having that certainly helps, because I've had colleagues of mine who were phenomenal at English, who would write brilliant one-pager documents and six-pager documents, and I got to learn a lot from them, right? So it's something that can be learned and picked up on the job. So don't worry too much about it. How is TAFR for placement? I don't think TAFR has placements, to be honest, because TAFR doesn't care. And that's fair if you think about it from their perspective. TFR's objective is not to generate graduate students. They tell you very clearly that we don't have a master's program, we only have a PhD program. If you want to join for a PhD in computer science, only in these areas that we focus in, join. Of course, if you finish all the coursework and if you don't want to continue, they'll give you an MSc degree and let you go. But that's not their objective. They don't care about placements, because their focus is core center research in fundamental areas of mathematical computer science, and they do a terrific job at it. And I mean, if you're thinking about placement, TFR is not the place to go, because the environment itself is very research focused. But I've seen people who have graduated with PhDs in TFR, and they've done phenomenally well in the industry, like phenomenally well, because their mathematical thought process and rigor is so damn good that, like, if you have specific areas of computer science, especially mathematical computer science and stochastic processes and things like that, that you're interested in, I think TFR is a better place than almost any major university in India, to the best of my knowledge. Is VIT good like triple IT? I don't think so, at least in my limited experience. I think triple IT is, especially Hyderabad and Bangalore, and certainly Hyderabad is at the top. I mean, I would compare triple IT Hyderabad with the top IITs, without doubt. I don't think VIT is still there, to the best of my knowledge. Again, I may be wrong here. I've seen their curriculum a couple of years back. So somebody says, students who start their preparation in second year, will they be able to get AR 100? No, there are no guarantees like that. You can prepare for GATE for 10 years and not qualify. That's the thing. It's not just about duration of time you put in. That is certainly needed. A certain threshold is needed there. But what is important is foundational understanding, and most importantly, problem solving skills. If you have that, you can easily get into a very good rank. Top 100 is fairly doable. So IIT KGP is a decent place. Again, if I have to rank it, it will certainly be below IIT Bombay, certainly below below IISc, even IIT Madras with respect to machine learning. Again, I don't know all areas of computer science. My limited knowledge, especially at research level, is limited mostly to machine learning. So IIT Delhi is again good. Kharagpur is pretty good. Don't worry about it. It's in the top league. Again, in the long run, whether you go to IIT Kharagpur or you go to IIT Kanpur or IIT Bombay, it doesn't matter as much. It's your skills that will matter in the long run. So don't get too bogged down on, even if you go to an NIT or triple IT, in the long run, it really doesn't matter. Nobody cares. It's all your skills that you possess and what you can contribute to an organization or institution that matters. So don't get too caught up on it. If you get KGP, if you're not getting, let's say, IISc or IIT Bombay, go to Kharagpur, or KGP is a short form for Kharagpur. Cool. Nice question. So Rajiv says, why is GATE not as tough as JEE? Because we would get good rank if it's tough. The problem with GATE is the vastness of syllabus. If you observe, except for UPSC civil services, every exam in India that I know of or that I can think of, if the syllabus is vast, the question paper is not very hard. In JEE, you only have physics, math, and chemistry, literally 3 subjects. The syllabus is so limited. In CAT, you have verbal and quantitative ability. The syllabus is limited, and hence the questions tend to be harder. In GATE, the syllabus is vast. And the reason for the vastness of syllabus is when you're writing the GATE examination, you don't know which area of computing you would go into. So they want to check, do you have the basic understanding of the breadth of computer science? It's a test of breadth, not so much of depth. And that's why most GATE questions tend to be easy to medium. If GATE questions were made hard, then GATE would be like UPSC Civil Services exam, right? So UPSC Civil Services is probably the hardest exam because both of the vastness of syllabus and also the hardness of questions. I've seen some of their math questions because they don't have computer science, if I'm not wrong, as an exam. So they're really, really good questions, especially in the mains. I've never taken it, but I've seen the questions just to get a sense of it. So somebody says, can I ignore English in aptitude? I'm not good at it. Don't ignore it. Even if you're not very comfortable with English, you can score some easy marks. So don't ignore any subject. In every subject, there will be easy questions where you can easily score a few marks. So don't completely ignore anything. So in terms of placements, IIT versus IISc curriculum, if you're purely placement focused, I think IIIT Hyderabad has the best curriculum to the best of my knowledge. Then some of the IITs and NITs also to some extent, but I would actually go to IIT Bombay, etc. If it's a curriculum for a placement-driven system. IISc is purely research-centric, to be honest with you. I mean, that's their goal. Their objective is fundamental research. Of course, they also take master's students, not just PhDs like TAFR, but their core objective is very clear that we are a research institute. They're very, very clear about it. So their coursework is fully aligned with it, not so much aligned with placements, but you learn the rigor that placements, even if you prepare for a month, you can comfortably crack them. Cool. Okay, I'm just looking for more relevant questions here. So Dharmesh says, why students prefer MS rather than MTech? Again, if you're getting into a top 20 universities in the US, an MS makes a lot of sense because of 2-3 things. One, the course curriculum at the top 20 universities is way better than anything that I've seen at Indian universities. The pool of students that you'll interact with, because US attracts the best minds across the world, you will get to experience much higher level of competition and hence learn a lot more through that competition. Number 2. Number 3, it opens up doors very easily through the whole. It's called something. It's called some. After you finish your masters, you can work for a while before you apply for your work visa, right? So it's called EBT, something like that. Okay. So that's also a very, very useful thing, especially if you finished your masters and you have some loans that you have to pay. If you go to top 20 universities, your chance of getting into a top company is fairly high, and you can pay off that education loan that you've taken. And in the long run, people who want to settle in the US, certainly a very good option, right? So people have that for sure. It's called OPT. Thank you, Basu. Yeah, it's called OPT. I forgot what it was called. So Aditya says, if you get 700 rank, should I go to IIIT Bangalore or prepare again? Please join IIIT Bangalore or an equivalent institution. Don't drop a year, because in the long run, it really doesn't matter. If you go to IIIT Bangalore, work hard, learn the skills that you need, you can get into the top companies just like the way you would get it if you go to IIT Bombay or IISc. It really doesn't matter in the long run. Cool. Ayush says, can I settle in US after masters from India? So one path that I've seen a lot of people from my own batch, from my seniors and juniors who have moved and mostly settled in the US is they finish their masters at a good university in India, get into a top product-based company, work there for a few years, they do an internal transfer, all right? And then they choose to work in the US for a few years in the same company, or if they're bored, they change the company, they change their visa structure. It's very easy to settle down. I mean, it's not a big deal, to be honest with you. So Aditya says, in some subjects like computer networks, I had to see videos twice to understand everything. That's perfectly okay, Aditya. There will be some subjects that you will find hard, some subjects that I will find little hard that I have to revisit, especially in computer networks, all these packet sizes, all of those details, right? I forget them every time. So I often go back, write the notes, revise and things like that. So there are some topics in the whole GATE syllabus that we all have trouble with. So that's perfectly okay. Don't worry about it. So what is the minimum rank that we should aim for a good institution? So I would say that if you're a general category student, if you're less than 300, I think you would get a very good institute. If you're less than 500, you'll still get a pretty reasonably good institute. Like I would like, if I were a student today and if I got, let's say 700, 800, if I got an admission at IIIT Bangalore, I wouldn't drop a year. Like I wouldn't even think, in retrospective, of course, given all that I know today. Like if I have a brother or somebody or a cousin who is taking it, I would say just go join, excel at IIIT Bangalore, get into the best of companies from there, and the world is yours. Don't waste a year. Cool. Again, general guidance about balancing college work and GATE. I would say, again, college work is chill as compared to actual work at a company where there are more deadlines and things like that. Try to cater about 2 hours before you go to college, and in the breaks of the college, try to sneak in some revision, or maybe if possible solve a few problems in between your college breaks. And at the end of the day, spend about hour to hour and a half. I think you're on good track if you do that. Somebody is asking how to revise while preparing. Again, there is a whole dedicated video on how to secure 55 plus marks in GATE 2022. Please check it on our channel. For each of these, there are very clear details about it. So please check it out. Okay, I think most of the other questions have been answered in the previous sessions or otherwise. But how is MTech at BITS Pilani? I wouldn't join it. Let me put it that way. I wouldn't consider it very seriously. Well, it's okay because BITS Pilani has a work integrated program. If you're a working professional and you don't want to take a break, it might be okay. But if you're going through GATE, I wouldn't take it very seriously because it's not comparable to IITs or IIITs in terms of both curriculum, faculty, research, and things like that. Of course, the BITS Pilani undergrad students are very good. I think most institutes or universities become good not because of the university, but because of the students, and of course, partly due to faculty. So, yeah, that's what I would suggest. So somebody says, can I join ISRO or DRDO through IISc or IITs? Some IITs, and I think for some years at IISc, these institutes do come for placements. But if you studied at these institutes, getting into organizations like DRDO or ISRO should be fairly straightforward. I mean, you can also crack their examinations if you have cracked GATE, right? And some universities have a direct entry to, I think, Scientist B or one of those levels directly after your master's program. So that's certainly, I mean, I know people who have gone through that path, and it's fairly straightforward if you've studied at IIT or IISc. So Rajesh says, will my BTech matter if I, for good IIT along with good GATE score? Not so much. I mean, GATE is thought of as an equalizer because there are so many universities in India, right? How do you compare, let's say, 80% from Andhra University to 70% from Anna University? How do you compare these two marks? It's so hard, right? Because every university has a different curriculum. Of course, they all follow broadly AICTE norms, but their examination level is so different. I know at least 3-4 universities in AP, Telangana, Tamil Nadu, Karnataka, etc., where the level of examination is so widely differing. Now, how do you equate that? So that's why GATE has been created an exam wherein whatever stream you come from or whatever college you come from, this is an equalizer where you can prove your skills to get into admissions into top universities. As simple as that. How much does it matter to score good marks in your masters? Nice question, Varun. So most companies have a CGPA threshold when they interview, especially the top 10 companies that come for placements. And the reasoning behind it is, imagine, let's say Google or Amazon goes for placements to IISc or IIT Bombay. They may not have time to interview everyone. They need a filtering criteria. So there are two filtering criteria that are often applied. One is CGPA cutoff. As long as you get, let's say, 8, more than 8 out of 10, or IISc has out of 8. So as long as you're 6 plus out of 8, I think it's not a major problem, number one. Companies also conduct simple screening tests on campus. So that's another way that other technique that they employ to shortlist candidates. Sometimes in conjunction with CGPA, sometimes they just ignore CGPA and say, hey, anyway, we're conducting a test, let everybody take it. The top 20 or 30 we will interview, right? Simple logic. A very nice question from Ellen. How to deal with post-practice test demotivation? Very nice question. Again, this happens to all of us. To be honest with you, it happens to me also when I have something slightly harder which I'm not able to crack. Happens to all of us. Just spend time, probably that day if you're too demotivated, take a break, do something that you enjoy, eat good food, spend time with family, friends, whatever helps you, and keep an open mind and debug what went wrong. The debugging process is very, very important. So we have a video on how to improve your problem solving skills in Gate. It's there on our YouTube channel. I think it's a 15-20 minute video. Please check that. We ask you, we actually explain how to debug that. Be truthful to yourself. This is an exercise you're doing for yourself. Debug why you got low marks and work on the mistakes. It could be silly mistakes, it could be conceptual gaps, it's lack of practice, whatever it is, work on those. Because that's how you can get out of your demotivated state, number one. Number two, you have a constructive path to keep improving your marks over the next few weeks. You keep doing this even for 4 to 5 weeks, you'll see significant results, significant improvement in your results. Okay. How much of MTech curriculum is placed related to placements? Very little. So again, most universities have a purpose that they don't want to be placement preparation programs, and that's fair. The purpose of an MTech is not just to prepare for a placement. That's very important, right? So probably only 10 to 20% of your actual curriculum, mostly data structures, algorithms, maybe some programming assignments, that will be like what, 10-20% of your whole curriculum. 80% of it will still be foundational computer science, pushing the boundaries. Like 80% of what I learned, again, I got into a machine learning role, so a lot of what I studied in my master's was helpful in the long run. But there are also some areas, for example, I learned a little bit of game theory here and there. I learned randomized algorithms, approximate algorithms, which are useful in the long run, and they taught me to think very critically. I learned graph theory from a pure mathematical standpoint. I've not applied most of that graph theory in the real world, but it built that thought process in my head on how to think clearly, that problem solving mindset, that rigorous thinking mindset, right? That's something that will stay with you in the long term, not just placement. So most universities, it will be less than 15-20%. Cool. Sounds good, folks. Nice discussion that we have had. Again, see you on the Friday with the next live session. Thank you very much. Bye-bye.